Periodic motion. Periodic motion is a type of motion in which the body repeats its path time and again. When we define periodic motion, there is no limit for the distance traveled, or there is no border or boundary for the time involved. Periodic motion might be that of electron around the nucleus, and at the same time periodic motion is that of sun around the center of the galaxy. Means time could be any value, path may have any shape, periodic motion is only the repetition. Now, one step ahead, oscillatory motion means to and fro motion. You choose one particular point, the body or the particle goes this side, that side, to and fro. That means if the motion, periodic motion becomes to and fro, it is called oscillatory. Simplest type of oscillation could be defined as simple harmonic motion. Simple harmonic motion simply because it is represented by sine and cos functions which are harmonic in nature. Their name itself is harmonic. That's why these are called simple harmonic motion. Now you see a particle having larger amplitude. What is amplitude? Amplitude means a fixed point around which to and fro motion takes place. The maximum displacement from the mean position, that is called amplitude. This would be known as amplitude. This is fixed or mean position. Extreme position up to which the oscillating particle goes, that limit. You see, oscillation and vibration are very minutely discriminated. Oscillation a bit larger amplitude, and when you talk about vibration, it is very, very small amplitude oscillation. Now, how to represent? SHM could be defined, simple harmonic motion, the simplest type could be defined as the motion in which the acceleration is directly proportional to the displacement. Alpha proportional to x. You see, normally alpha represents angular acceleration, but here we are using this term for angular and linear, both the acceleration alpha. In simple harmonic motion, alpha, that is acceleration, is proportional to the displacement. Now, if you use one proportionality constant, this would become alpha minus kx. K would be the proportionality constant that we'll find equal to omega square. Why the minus sign? Minus sign indicates that the acceleration is opposite to the displacement. Now, a body starts from this very point and goes to right side, your right side. Then displacement is this way, and the acceleration is opposite to it, simply means that some force is acting over there which is opposing the displacement. Or other way you could say that force is in such a manner that it will try to bring the oscillating particle back to the mean position. That's why this special force is named as restoring force. So, in simple harmonic motion, there is always a force named as restoring, that is proportional to displacement, and that is always opposite to the displacement. Certain definitions you will come across. Amplitude. Amplitude is the maximum displacement that takes place here, as I told you. And you see, this is the mean position. Body goes to this extreme, returns to mean, and then goes to next extreme, returns to mean. Now, one complete oscillation has taken place. The time involved here would be known as time period. You see, if you count the number of oscillation in 1 second, that very number would be known as frequency. Time period and frequency both will be related this way. For frequency, notation is used sometimes f and sometimes n, sometimes even nu, Greek letter. Nu is also used mostly in mechanics. We use this term nu for frequency. Angular velocity is 2 pi into n, that is frequency. Omega is angular velocity, or you might say this is angular frequency. These are the definitions we'll come across. You see, SHM is always represented by the equation in which sine or cos functions are involved. Here in place of sine, you could replace it by cos also. X is the displacement at a particular time t starting from mean position. Omega is the angular velocity. Omega t as such would be known as phase plus phi. Complete phase is omega t plus phi. This is the complete phase. Put t equal to 0, you find phi. Phi could be known as initial phase. Initial phase is also known as a technical term epoch. Its name is technical name for initial phase is epoch. And this omega t plus phi as a whole is known as phase. After sine, cos, tan, cot, you normally use the angle. Here too, this is the angle. That's why its unit is going to be radian. Remember, amplitude can never be negative. Displacement could be positive, could be negative, but amplitude, as far as the amplitude is concerned, is always going to be positive. And the values I have given over here for time period, this is 2 pi by omega, omega 2 pi n, and in place of n or frequency, you could write 1 upon t. So, you could relate in different formats. You will be having choices with you. This is in tabular form I have given over here. Then how to represent graphically this equation of simple harmonic motion? Because it is harmonic in nature, that is sine function or cos function, so it is given this way. Though we have chosen conventionally y-axis here, but this is displacement along y-axis. Time is taken this way. Time period means one complete oscillation. That means the body starts from mean position. Again, it is restored. The time involved is known as time period. This is going to be the half of the time period.